Today, we are going to introduce the most powerful segmentation model in history, SAM 3.1. The biggest feature of this model is using natural language to segment the objects we need from images or videos. This video is mainly a guide to avoiding pitfalls. I believe this model will have no problems performing on general images and videos. But when it encounters complex compositions and videos with frequent camera cuts, there is a high probability it will fail. Today, we will use one video to clearly explain how to correctly use the SAM 3.1 model under various complex backgrounds. So where can we try out this latest segmentation model? We provide two methods for you. The first one is you can go to Meta's official website. As Facebook's parent company, Meta has always been dedicated to the research and development of segmentation models. You can click Try the Background to enter the SAM Models Trial interface. The scenarios we commonly use are mainly the first two. One is for videos and the other is for images. Here, I will use a video as an example to demonstrate for you. We click Create Video Cutouts. At this point, you can upload your own video. Of course, you can also choose the sample videos it provides as basic material. Here, I will just choose this first video to demonstrate for you. The system will then do a basic analysis of the video, mainly to extract the objects that might be used inside it. Next, we can describe the object we want to extract. There are two ways to describe it. The first one is you can choose directly from this drop-down list. This list is actually what the system identified itself during the video analysis process just now. If you find that the thing you want is not in this list, you can use your own natural language to describe it. Now, I will set the object to be extracted to female. You must pay attention here. The SAM model's video segmentation has to go through two stages. The first stage is to perform object segmentation on the image corresponding to the current frame. So take a look, there is a button here called Preview Frame. When you click it, it will extract the female in the current frame. Then we will enter the next stage. In the next stage, we need to do a video search. It will use the current frame as a baseline to search the entire video and then extract all the objects in the video that meet the condition. Later on, you can also add some special effects, like highlighting or turning the background into a green screen. Personally, I feel that this official SAM model is very easy to use. The only drawback is that you have to wait in line. So we also provide you with another method, which is to use this model within ComfyUI. And this is the main focus of what we are explaining in this video. Currently, official ComfyUI already supports the SAM 3.1 model. You can download this model from the Hugging Face repository. I need to remind you that this model is a checkpoint. That means the model you download, besides the main model, also contains the encoder. Because of the model's own characteristics, there is no VAE inside here. You will find that this model is not large, but if you recall, the sample video we just processed was 9 minutes long. This is enough to prove that this model's performance is incredibly strong. We just need to download this model and put it into your checkpoint directory. Besides that, we also need to update ComfyUI to the latest version, because if your version is relatively old, it might not natively support the SAM 3.1 model. To make the demonstration easier, I have also built the workflow on Running Hub. In the ComfyUI space, Running Hub is a fantastic online platform because whenever a new model or new extension appears, it always follows up immediately. Additionally, Running Hub provides an online communication platform for ComfyUI creators. You can find a lot of inspiration and sample workflows on here. All right, next we will analyze this workflow for you. Just now, when we introduced this model, we also mentioned that this model can be used for both images and videos. There are two kinds of workflows for it. Let's first look at its application in images. The image segmentation workflow is extremely simple. First, we need to use the load checkpoint node to load the model. Then, we upload an image. Currently, this image is quite normal. 2 boys and 1 girl are dancing. Then we enter the prompt in this text input box. What I enter here is male. That means I want to segment out all the male characters. Here comes the most important node. The name of this node is SAM3 detect. It has 3 inputs. The first one is the image we want to segment. Additionally, there is the encoded positive condition and our main model. As for the remaining 3 inputs, we generally rarely use them. Its outputs are our mask and the bounding box from our edge detection. Here, we can use draw box to draw this edge detected bounding box. Then we use the Draw Mask on Image node to draw this mask. Here I set the mask color to purple. Then you can see there are two outputs here. Did you notice what is wrong with these two outputs? Pay attention. Even though we requested to detect all male characters, we ultimately only detected the one on the far, right? It seems we missed one. So this is the first problem you need to pay attention to. The SAM 3.1 model itself has a very high reliance on prompts. If you find that the prompt you are using cannot correctly segment all the objects, then you need to adjust your prompt. But the direction for adjusting the prompt is not to make it more general, but to make it more precise. For example, with this just now, if I change the prompt to left male and right male, you will find that both male characters can be perfectly detected. If we change the prompt with the opposite mindset, for instance, changing it to all male, you will find that what we finally get is still just the boy on the right. The one on the left does not show up. Therefore, you must pay attention to this method of writing prompts. If you feel this example still doesn't explain the problem clearly, let's look at a more outrageous one. In image detection, the complexity of the image itself also greatly impacts the detection result. For example, the image below. In this image, there are actually 7 people. They form a hexagram pattern in an extremely complex way. There is a very complicated occlusion relationship between their arms and bodies. At this time, if you want to use one single prompt to segment out all the male characters, it is basically impossible. In this situation, our prompt should still follow the principle we just mentioned. Try to write it precisely and then combine them. After testing, you will find that if we respectively use the following prompts, male in red t-shirt, male in yellow shirt, male in blue shirt, male in white shirt, we can locate the 4 male characters in the picture one by one. Then we join them together with commas to generate a combined prompt. By using this prompt, we can extract all the male characters completely. But if you want to use just one prompt to extract all the male characters, it is very difficult. So through these 2 examples, I hope you are clear on how to write good prompts. Next, let's look at video segmentation. When we demonstrated the SAM 3.1 model on Meta's official website, you already saw that the segmentation model needs to go through 2 stages for video segmentation. The first one is to perform a detection on the image corresponding to the current frame. Then, based on this detection, it tracks or searches the entire video. In the ComfyUI workflow, it is the exact same process here. We must clarify in advance. The videos we process generally come in 2 types. The first type is a single take video. The second type contains multiple camera cuts. To be accurate, the SAM 3 model can handle both single take and multi-shot videos. But when you use it, you need to apply some correct methods and techniques. We will explain this in detail for you shortly. Here we have chosen a highly representative video for you. 2 classical beauties with distinct Eastern features are fighting. Why do I say this video is highly representative? Because it contains both a large number of camera cut segments and a very stable single take segment. First, let's analyze this workflow. We load a video, and then we first grab one image from it to perform object segmentation. Usually, we recommend you choose the first frame. For example, the image we selected is a beauty wearing a long white dress and holding a sword. The overall feel is quite good. Below that is a typical image segmentation process. This is identical to the process we just talked about. The prompt we use is beauty wearing a long white dress. This way, we can successfully segment this character out of the image. Then, we will use another highly useful node called SAM3 Video Track. This node can use the current segmentation result as a base to search the entire video to find the object we need. The inputs for this node are very similar to SAM3 Detect. The only difference is that we need to pass in an initial mask to act as a reference for searching the entire video. Then you can use the SAM3 Track Preview node to preview the overall segmentation effect. You can see that during this preview process, many objects have ID numbers on them. And below this ID number, there is a number. We call this number the confidence score. The higher the confidence score, the more accurate the segmentation is. You might have also noticed a special object in here, which is the object with ID 0. This one doesn't have a confidence score itself. So what is this object 0? It is the original object you found during the image segmentation. Logically speaking, no matter how the camera changes, this object should be tracked very accurately. But sometimes there can be errors. For example, in the frame below, the girl wearing the black dress is also regarded as object 0. This is definitely incorrect. But you need to be aware. There is a situation where object 0 does not exist. For instance, in the example below, I directly used the 200th frame as the reference image for object segmentation. Then you will find that in the result, there is no object 0. Personally, I feel that in this situation, this kind of segmentation has no reference value. Therefore, we strongly advise you to always use the first frame as the reference image for object segmentation. This way, object 0 will usually appear. To ensure our segmentation is accurate, we will use a node called samTrack to mask. This node on one hand can convert the object we are tracking into a mask. At the same time, it allows us to input an ID number. This ID number is exactly the object ID we just saw. For example, if I write 0 here, this way I can preserve the original object throughout the entire video. Of course, you can also enter any object ID you want here. Through the demonstration above, you can see that SAM3 is a model with incredibly strong segmentation capabilities. It can accurately segment objects from images and can also very accurately segment objects in videos. But to use this model well, you still need to master the techniques we just mentioned. The first one is how to write prompts. Do not try to use one general prompt to segment all objects. Instead, try to write detailed prompts for each object and then combine them. Also, in video segmentation, we must go through 2 stages. The first stage is selecting an image and segmenting the object. This way, object 0 will appear. Then, during tracking, we can filter based on the ID numbers. This way, the result we get is the most accurate. Alright, that is all for today. What are you waiting for? Hurry up and try it yourself. Follow me to become someone who understands AI.